I'm now going to introduce another way you can factor. This is called factoring by grouping, and it is always used when you have 4 terms. You would never use factor by grouping if you have 3 terms because you can use a different method. So the big idea here is you break things into groups of 2, and then you see if there's anything in common. And hopefully those groupings of 2 will allow you to then see a pattern in the remainder. I'll start off with this first one. I'm going to start out by drawing a vertical line in the middle where there are 2 terms on the left and 2 terms on the right. Then I'm going to see if there are any common factors in the first 2 terms and any common factors in the second 2 terms. I can see there's a common factor of A in the first grouping, and I have C plus D left over. If I look at the second grouping to the right of the vertical line, I can see I have a common factor of B. And C plus D is left over. Well, that's convenient because C plus D is what I had on the other side. So we now have 2 binomials that match, and you want to drop the sign between the 2 groupings down. C plus D is my binomial factor that I'm going to pull out front. What do I have left over? I have an A and I have a B. And I have now factored this by grouping. And the pattern holds. It's quite cool, actually. So we're going to drop a vertical bar down between our 4 terms. So 2 are on the left and 2 are on the right. We're going to see if there are common factors. On the left, t squared is a common factor, and we're left with t plus 6. On the right, we have a common factor of -2. Pause, notice if the term directly after the vertical bar that you made is a negative, you will always factor that negative out. So that's what I did right here. If you factor out a -2, then you'll be left with a positive t plus 6. Now you might be thinking, well, there's a -12 here. Well, if you distribute that -2 back in, you will get a -12. And notice that now our binomial factors match. So we can factor them out front. T plus 6 is my common factor that I pull out front, and t squared minus 2 is what's left inside. Now don't be fooled. You must do one more step. This is not a difference of 2 squares, but it might be, and so you have to be very careful to check this leftover piece to see if one of them squared. There's a good chance you could still keep factoring. In this case, you don't have to. You're good to go. Now let's look at the next one. I'm going to drop a vertical bar to separate this expression into groups of 2. I'm going to look at the left side and have a y squared in common. I'm going to look at the right side and I have a plus 3 in common. Now I'm going to see what's left over. When I factor out the y squared, I'm left with y minus 1. When I factor out the 3, I'm left with y minus 1. And that's good, because now I have a y minus 3 as my common binomial factor. I will pull that out front, and I'm left with y squared plus 3. The sum of a square and a prime is not factorable, so we're done. Let's look at this last one here. We have a 2xy minus x squared y and a -6 plus 3x. If I take that xy out, I'll have a 2 minus x. Now if I were to factor out a -3 on the right, I would be left with a 2 minus x. And so my common binomial factor is 2 minus x. I take that out front, and I'm left with xy minus 3.